Hello, thanks for being here. Thanks for having invited me. Yeah, my talk is a little dry, perhaps. Let's see how it goes. I'm interested in linking recursion to questions not only of computation, but also of discourse creation. And because of that, I'm looking forward and backwards until the beginning of the 20th century. Recursion is traditionally comprehended as a process of repetition in a self-similar way. While recursion is most often associated with mathematics and computer science, I will use the term more generally to describe a condition of history as a continuous reoccurrence of past tendencies and discourses. In that respect, the here developed concept clearly departs from other 20th century conceptions of history characterized through epochal ruptures, epistemic breaks like Gaston Bachelard, evolutionary paradigm shifts like Thomas Kuhn had proposed, and discourse formation and reformations as Michael Foucault had proposed. A recursive theory in history of architecture follows not only its epoch's own logics of discourse and production, but also the logics of assessment and historization of past epochs. And I think there is an importance here right now to reinvestigate in the questions of the past as much as in what we're searching for as being the new. Recursion is a return and a reorientation of a discourse. It is repetition and difference, self-reflection and self-correction. A recursive architecture theory and practice, however, does not suggest a return to tradition. It is rather a promise, a thought, which is based on an increased understanding of the past and present complexities of architecture production, a new and different multi-layered writing and reading of architecture. The underlying model for a recursive theory and history of architecture is a conceptual machine, which is called the Turing machine. The Turing machine was developed in 1936 by Turing, and it's the principle of computation. And it's a recursive machine, which is very important, as I will differentiate between recursive and non-recursive machines. The Turing machine is consisting of a writing head, which you can see, this is like this black arrow on the bottom. See here? This is the writing head. And in this box, you see the program, which is comparable to today's computational programs, and they're very simple rules, which we call the algorithms. And these rules define in how far this reading head is moving back and forth, and either reading a 0 or a 1, which means off energy and on energy. So the Turing machine is consisting of this head reading and writing on a tape according to a set of rules. This machine was the precursor of computation and presents the principle of computation. The operation of the machine depends on the rules provided and thus changes as we would change the rules. However, as we can easily understand, computation as such is not associated with a particular form. Rather, on the contrary, the power of computation lies in the fact that a diverse set of data can be transposed into different formats, such as images, sound, or movement. So what I'm interested in is, first of all, to figure out that this machine has nothing to do with the images we usually produce, because simply this machine does not know image as such. It knows the production of data of a sequence of 0 and 1s, but that's about it. So the question then is, how do we receive our images, or why do our images look the way they look? Now, if we look more carefully at this system here, essentially, this reading head here, for example, is writing a tape, and by doing this, it would do an output here. It would reprogram this Turing machine, and then this Turing machine again would reprogram this one, and so forth. And so essentially what we're receiving here is a kind of, you could say, a feedback loop between different sets of Turing machines as they continuously rewrite upon each other. And we could say this is a more complex recursive system. While trivial machines continuously repeat the one and the same task they have been designed for, the non-trivial machines, and the Turing machine is a non-trivial machine, and therefore also any computer could emulate other machines, which I just showed you here. So essentially you could imagine one would be functioning as a radio, the other one would be functional as a drawing machine, etc. Through the programming, we make essentially the Turing machine to that what it is, and we also define through that the output it will produce. Potentially in a feedback loop, the machine's operation could be altered through its own output. Non-trivial machines consequently have the capacity to repeat the operation, yet may repeat it indefinitely, differently, so the previous occurrence is never the same as the following. Non-trivial machines are therefore recursive. The shift from trivial machines, and trivial machines are those which we know as pretty much any other machine, particularly those used for mass production, they repeat just the same. Non-trivial machines repeat difference, and this is very significant. And this shift I'm describing right now from the trivial to the non-trivial machines is similar to the shift from tools to handcraft to the arrival of the trivial machine and the industrialized mass production. Without doubt, the shift we're witnessing since the arrival of the non-trivial machine computer after the Second World War is very important and is noticeable. Because if we look at it carefully, we have a shift from mass production to mass customization, and therefore we also will have a shift in the aesthetics, and that even though the computer as such is not really linked directly to an aesthetic in terms of its production. So in where we are currently is then, in the sense of today's situation, we can then see a recursion of the past in the way that we could say we have another shift we're just witnessing, which is comparable to a shift which happened at the end of the 19th and the beginning of the 20th century with the emergence of machines which were very suited to repeat exactly the same continuously. Currently, we have machines which are not repeating the same, but they are repeating differences. And that's a very important aspect, I think, and we can see this continuously influencing our work. And I would hope also in not only our work, but also in terms of how we produce discourse and how we may think about our work. The fascination of today's architects with the logics of computation can equally be understood as a recursion of the past, and yet another past, not the just past I have mentioned, but with the past immediately after Second World War, when also a fascination with the same subject matter, namely computers, was apparent. And I'm talking about the time period about 1950s and 1960s. So I suggest to look now at ornaments, and this is what my talk will be about. Ornament is being the direct sign of their time, meaning also as being a direct sign of the production processes that set them forth, but not only production processes, but also the discourses. Substantiating the recursive nature of the practice and discourse of architecture, I will now be looking at ornament as sign of its time. Recursions, discursive, formal, or technological, allow not only for a returned occurrence, but for an occurrence that is marked through its variation from past discourses and developments. Recursion ensures both at the same time, repetition and difference. The shift in the history of ornament in architecture coincides with shifts in the logic and media responsible for the production of architecture. With each shift, comprehension of the role and perception of ornament in architecture was altered. Ornament can thus be seen as an indicator of technical and discursive change in architecture, a sign for the recursions within the discourse. Already Krakauer suggested in 1927 that, I quote, "The position that an epoch occupies in the historical process can be determined more strikingly from an analysis of its inconspicuous surface-level expressions than from that epoch's judgments about itself." The surface-level expression of ornament will be here in my presentation showcasing in how far the technological means that produced it are trivial machines, meaning non-recursive machines, or non-trivial machines, meaning recursive machines. All ornaments that were produced through the mechanical processes of mass production, for example, are those of non-recursive logic. At the beginning of the 20th century, ornament became the subject of an intense debate as methods of production, labor organization, and objects themselves changed. For Henry van der Velde, the role of the ornament had significantly changed the end of the 19th century. Ornament becomes an organ and refuses to be something just glued on. New with our theory is that ornament has no life of its own, but rather is dependent on the object, its forms and lines, and will receive through those its organic and correct space. With other words, ornament, as we can see in this image, has turned itself into the object. This type of ornament had little to do with the figurative ornament of the 19th century, but rather suggested ornament as a set of abstract lines constituting a surface. Ornament became an important codependent organ of an artwork's organic whole, working itself as extreme into such objects as a child's cradle. Critical of previous practices of ornamentation and in opposition to Werkbund members such as Hermann Muthesius, van der Velde nevertheless still linked ornament to the arts and craft of individual artists. At the same time, ornament around 1910, Muthesius and others at the Deutsche Werkbund contended that industrial production challenged the traditional significance of ornament altogether. When machines enabled application of ornament to any object, ornament traditionally tied to handcraft and materiality now became widely remarkable decoration. Here we see an image from the Berndorfer Metallwarenfabrik, which is a fabric which just produces those, and it's a little unclear, unfortunately, but what I want to point out is here, so essentially this is the same set, it's a repetition of the same from a, what I would call trivial machine, and the only difference is that the ornamentation of the silverware has been changed, and this of course has been imprinted. So this was a very great business, had nothing to do with handcraft anymore, had also very little to do with art if you want, and was merely the resultant out of the newly developed machinic processes. For many architects and designers in Germany, ornament embossing machines represented the efficient destruction of ornament's social and artistic value and relevance in modern society, as exemplified by the cutlery and vitrines of the Metallware Company. Muthesius summarized the problem. Precisely because a machine is burdened to mass-produce ornament, a description of bad ornament has resulted through which the artistic level has reached a distressing low. For Muthesius, the industrial fabrication of products and the accompanying mass distribution of decoration degraded ornament. Trying to account for these changing conditions and the effects they would have on ornament, Adolf Loos proclaimed in Ornament and Crime, I quote, "We overcame ornament. We brought ourselves to an absence of ornament. Ornament is dissipated workforce and thus dissipated health. It is also dissipated material and thus dissipated capital. The manufacturing of surrogate art and add-on intarsia, imitating handcrafted ornament through industrial means, appear to Loos to be a kind of crime, not only for the aesthetics it popularized, but maybe even more so also because of the devastating social-political milieu in which industrially applied ornament was produced." I think this kind of social-political agenda, which we hear here in this criticism, is something we, I think, have pretty much forgotten about these days, but maybe it's worthwhile to rethink in the way how we do ornaments maybe today. Loos' critique responded to the increasing alignment between ornament and fashion, which sought to encourage consumption beyond actual need. Slightly altered variations of the same goods were successively produced so that a model's age could be easily detected, and fashion worked to create the slightest difference, often displayed in the easily ornamented surfaces of consumer goods. The surface alteration rendered fully functional objects of prior seasons obsolete. Ornament was produced neither as an individual artistic expression nor for aesthetic reasons, but rather to stimulate consumption through the creation of arbitrary difference. Despite this problematic development, Loos, unlike his poorest followers, was not interested in the abolishment of all ornament. For as he suggested, quote, "Wherever ornament vanished as a sign of the times, it could not be reappropriated." But then on the other hand, where it still remained, it was still okay to remain. Yet it could be argued that the surge in the production of ornament at the end of the 19th century coincided with the rapid industrialization and urbanization of Europe. Consequently, ornament, as the artistic expression of an individual artisan, gave way to industrial-produced ornament, expressing the de-individualized mass production methods and society. Industrially-produced ornament is then nothing but a sign of its time. It is in this sense that we cannot speak from industrialized mass production as a recursive process, since the process remains the same and the product it marked through the repetition of the same. Mass production becomes a determining factor of life, even in the situations where one wouldn't imagine it, in recreational situations. And so we could argue maybe that here the human being is equally pressed into a framework as the matter is pressed into the framework of the non-trivial machine. German culture critic Siegfried Kracauer wrote in Ornament, the Mass Ornament, that the Tiller girls and their dance performance gave a new quality to mass ornament in which the individual component is submerged in the totality of the whole. I quote, individual girls merge indissolubly into girl clusters whose movements are demonstrations of mathematics. As they condense into figures, performances of the same geometric precision take place. The resulting ornament was not an expression of the inner logics of form and lines, the dancers, but rather a conception of ornament projected onto the constituent parts. For Kracauer, the ornamental mass of the Tiller girls, the structure of the mass ornament, reflects the entire contemporary situation of a society informed through mass production and standardization. Mass ornament was associated with Taylorism, which delineated workers' movement according to the dictate of the production processes overall rhythm. In both cases, the individual is detached from the actual commodity produced, and her individuality as a creator is subsumed into the overall process. The new mass ornament was not the result of expression of a community gathering or producing art, but of a formation of the mass, reducing the individual to a set of lines within assemblages of lines. The emerging ornament detached from its bearers and resembling geometrical figures retained little of the individuality of people involved. At the Bauhaus, Walter Gropius advanced a similar position and critique in Kunst and Technik, a new unity, by attempting to link the work of the artist with the modern production techniques and technologies characteristic of the 20th century. So instead of leaving the artist outside, the artist was now supposedly integrated. In contrast to former Bauhaus instructor Johannes Itten, who favored the artist-craftsman model and celebrated the singular achievements of the individual artist, Gropius envisioned a new artist-engineer whose work would anticipate modern industrial production processes. The work of art was hereby no longer thought as a unique product of a single hand, but designed to be serially produced. Gropius' lecture given at the opening of the Bauhauswoche, which is a Bauhaus Week exhibition, signaled to the international audience his desired conflation of art and technology. The Bauhaus became a school for training artistic Maschinenvolk, machine people, who in their critical adoption of modern production logics would, quote, no longer be threatened by the emergence of the modern world or becoming irrelevant to it, but would achieve its goals as part of this grand process, end of quote. Yet, the economic imperatives and the social repercussions of mass production were little reflected within this proposal. The work was judged for its modernity, itself defined by techniques of production and the alignment between form and function. Industry was favored over craft as ornamented, handcrafted surfaces were replaced through seemingly ornament-free surfaces. The death of ornament seemed certain, yet the plain industrially produced surfaces themselves became ornamental. This modern image of architecture exceeded by far the modernity of its actual construction, and in the end, many of the results of modern construction and functional logics were nothing other than a reintroduction of a disguised ornamentality. Construction elements themselves became ornamental. In other cases, the rejection of ornament turned bareness itself into ornament. And Gropius was not alone. The bare white wall, for example, turned out to be a rhetorical rather than rational choice. This became apparent when Le Corbusier published in 1925 a code of whitewash, the law of Ripollin, an essay in which he mandated that, quote, every citizen is required to replace his hangings, his damask, his wallpapers, his stencils with a plain coat of white Ripollin. In so doing, Corbusier writes, home is made clean. The whitewash is not only an erasure of ornament and decoration from architecture, but also a purification of architecture's look, and in the long run, also of its inhabitants. So now I'm shifting to the computer because we reached more or less the end of the discussion around the machines which are only capable of doing a repetition of the same, which of course Gropius and the Bauhaus were very interested in seeing what the repercussions for architecture are. We're now on the verge, meaning we're around the time frame of the beginning and the end of the Second World War, where through massive developments, the technology of the computer has been set forth. Ornament and form were radically rethought now with the arrival of computation. This seems surprising, as computation is itself not setting forth any specific aesthetic, as I discussed before. However, in the mid-1950s, advocates of information aesthetics, led in Germany by Max Bense and in France by Abraham Mols, believed the introduction of computation would further challenge commonly held ideas about ornament in art and architecture. Although computers were only available to a few mathematicians and programmers until the 1960s, the medium's very inaccessibility helped to fuel a theorization of the digital, first in art and later in architecture. This theorization coincided with practical tests at computer companies like Siemens. Computer turned almost accidentally into laboratories of information aesthetics. So what we're seeing here, for example, is one of the very early programs. And so this is it's called Zeichnerisch, so it's like a drawing table kind of format here, where a simple algorithm is describing in how far points will be moved. And the result you can see over here. Now, these programs were written by the first computer graphic artists, if you want to, but it happened that those were all mathematicians working for Siemens in Germany, who were asked to develop an interface which would allow to put graphics out of computers. Now, back then, you must imagine computers didn't have anything of the interfaces you currently have, neither keyboard nor a computer screen. So the only thing you would get out of them after you would have programmed something was a kind of large line of printouts where you could see whether you have been successfully programmed the computer or not. And because of this accident or this interest in, let's say, producing something to be printable and developing the printer essentially as one of the peripherals in order to ease the access, at least to the results of your anticipated computations, those laboratories of information aesthetics evolved, in which then those mathematicians, in collaboration with the philosopher Max Bense, would discuss what the repercussions, the theorizations, and then also the actualities of their work was about. In particular, information aesthetics suggested a close relationship between algorithms and aesthetic phenomena. And you saw this here, the algorithm, you saw immediately on the left side with the previous image that there was a direct equation between the algorithm and the outcome. Algorithms could not only analyze aesthetic phenomena, but also synthesize them. The first computer graphics and computer-generated architectures, simple organizations of patterns and structures, were developed in Germany as byproducts of computer testing. The understanding of authorship, the work of art and ornament, shifted once again. Programs written by computer programmers and / artists defined the realm of possibilities through which infinite variations in computer graphics could emerge. And you see here right now 3 of them are by Georg Nies. They were done in 1964. And here's another set of called 4 realizations out of a series. It's a walk-through grid done by Frieda Nake in 1966. Now that the organization of the surface could be rationally calculated based on the logic of computer programs, the dichotomy between the ornamental, considered playful and decorative, and the structure, considered objective and rational, began to dissolve. But computer-generated structurations were random syntactic patterns not to be equated with semantically charged ornament. Consequently, the successor of ornament, one could say, became the pattern. meaning pattern being syntactical, not semantically charged, ornament being semantically charged, meaning having meaning. This shift did not go unlamented. Art historian Hans Sedlmayr expressed the death of ornament as the immediate indicator of the loss of traditional values and imagination. He particularly criticized operations in which syntactical structures work free of semantic meaning as a precarious, even unhuman condition. In 1948, he argued, quote, "Lower agendas usurp the place of higher ones, change becomes the creator par excellence, and the pattern claims the illegitimate succession of the ornament." And again, in 1955, he says, "Senselessness becomes by all means the program, since the logical positivism drives any sense out of all terms and converts them to bare tokens." End of quote. For Sedlmayr, the predominance of syntactical structures dissolves sensory comprehension, and with it, the motivation for inherited representative ornament, which is replaced by senseless patterns and structurations of matter. He critiqued works of art and architecture that were thought as systems of formal relationships in which the emergence of a gestalt was understood as an ordering process following orders, that is, commands and the logic of aggregation. Sedlmayr's analysis suggested, albeit negatively, that the new information aesthetics was not limited to analysis and synthesis of pattern, but also reconceptualized human perception as the capacity to recognize patterns. In 1968, the art historian Hans Ronger assumed that human perception is simply a signal exchange that required recognizable structures to be perceived at all. Consequently, perception had to be based on a minimum level of periodicity, redundancy, and structuration. Even the interhuman exchange of information was envisioned as being conducted pixel by pixel, line by line. So, and what you see here is essentially, this is the eye perceiving a pixel, black or white, and the whole process behind the eye, which is our perception system or our brain, was considered as nothing but, you can see here, analog to the computer, a computational system essentially, which then would be able to detect as patterns would occur, and otherwise would just understand this as you understand it currently. So essentially the whole idea was that computation essentially evoked a new comprehension of how we see, and what is being seen was suddenly comprehended as being nothing but pattern, which we today call pattern recognition. And then the eye was scanning it essentially, which was also an analogy which they took from early televisions. That was how television would build up their image, and later on also how actually scanners would scan photography. So here another way, then of course the resolution as we all know it has to do with how much of an image we will perceive. Here of course the resolution is a little rough, and then increasingly the elephant is occurring as a proper elephant to us. So again, this whole comprehension and assessment of reality was nothing but a signal process. Several of the aesthetic productions in art and architecture began to reflect these theories of perception in the process, shifting the emphasis from isolated single elements and whole forms to structural patterns imbued with complexity of possible variations. Ronger argued that the human perception of a gestalt, structure, or system within the vast realm of possibilities would require order, in the sense of both command orders and spatial orders. Aesthetics, he concluded, unfolds in the tension between complete randomness and complete order. And I think these two images show quite nicely, you could say a lot of perhaps randomness, but then also you can see different type of orders, and there's not, and the eye jumps back and forth as it recognizes different types of gestalt depending on what you focus on to look at as being the organization. I think, frankly, a couple of projects I've seen last winter were also playing with these questions of gestalt and the emergence out of abstract pattern and randomness, the emergence of gestalt, which cost me also a little bit to present this today. For Ronger, it was important to find a balance between complexity and order, and originality and banality, because an unexpected order of signs must be comprehensible and memorable to be aesthetically satisfactory. So only if, in a moment you start to detect within this vastness of elements something which is recognizable to you, Ronger claims there is a degree of satisfaction. In 1970, this new idea of ornament was defined as a Raumfeld or space field. The new ornamentation obviously had little to do with the decorative and semantic functions of the previously known types of ornament. This new picture space is not perspectival, Klaus Hoffmann wrote. It is anti-illusionistic and multidimensional. It is a fluctuating, elastic space-time continuum, a space field, which emerges out of the ornamental structure, ornamental signs and ornamental figurations, and which results in phenomena between planarization and deplanarization. Artwork was seen to be constituted by multiple individual elements comparable to atoms and molecules, whose changing relationships allow for the space field's differentiation, and always changing over time, as you, when you watch these, constantly have a new type of relationship you establish. The structures structuring the image thus become the ornament. So my argument is here that only in the moment that a structure would be recognizable here, we could consider this being an ornament, because only in this moment this becomes semantically relevant to us in a way that we realize that as being, for example, a square. Essentially then, upon becoming reconfigured through information aesthetics and mathematics, the definition of ornament had changed. It was no longer the decoration of an existing structure, but rather derived from the rational structural organization of a group of elements. At the moment these first syntactical structural organizations turn into a gestalt, into a semantically comprehensible structure, ornament emerges. Any surface or space ornament is nothing but a moment of structuration, only one out of infinite possible realizations at a given moment in time. Ornament is set apart when its gestalt emerges and becomes recognizable, is seen as a part of, yet set apart from, a sea of singular element signs that characterize the new ornament. The initially chosen repertoire of signs, like the algorithms that regulate their structuring, became essential for aesthetic production. This framework of possibilities became the artwork itself. The departure from the object product and the turn towards the aesthetic process perhaps also initiated a departure from the ornament and a turn to pattern. In the moment ornare became ordinare, ornament was no longer interpreted as supplemented, but rather as an internally conditioned and thus essential expression. Ornament appeared in a new light as a rule-based possibility for the structuration of appearance, and you could say an extension for our perception to take place at all. Ornament is thus essential for any human realization. It is neither superficial nor added on, but rather the becoming of gestalt, the information of matter and of perception. In this context, ornament is essential for any realization that takes place. Perception here is comprehended as a recursive process in and through which ornament is set forth. The role of the designer is hereby to establish a framework in which this recursive activity takes place. The designer provides, instead of a unique design, the realm of possibility, the realm of possible designs. Since perception was conceptualized as computation, we have here an early example of a recursive computational process, and early means in the 1960s. So, of course, it's not a computation through a computer, but it's a computation through our brain. Now I'm shifting to the question of what are ornaments today. Within algorithmically generated ornamental structurations of the 1960s, the dialectics of affect and function, emotion and ratio, semantics and syntax were dissolving, and in their place emerged a new mode of realization and comprehension. Thanks to increased computing powers today, this development has multiplied 1,000-fold. Since the recursive process of computation cannot link to a particular aesthetic, it is quite remarkable how it has become associated in the past and also present with questions of aesthetics. In particular, the last years have seen an increased interest in linking computation to form, formation, and ornament. In particular, this development might be due to the arrival of the personal computer. The generation of form and ornament became closely linked with the logics of software, and thus may serve here again as litmus tests for changing design techniques and principle. Today, more than a century after Lowe's dismissed tattooing as degenerated and primitive and called Ornament a crime, architects are once again deeply entangled in discussions about and productions of affect-sustaining ornament, with some suggested effect as the essential and often sole function of architecture. Of course, this is a design from here, and I'm sorry that I show this, perhaps, who knows, but I would love to discuss this more. But not right now, but maybe later, because I have a couple of questions regarding this piece of work. I'm not sure the author is here, perhaps. I don't know who made it. I forgot to take this down. Sorry for that. So moreover, form and ornament are held to be essential for producing affect and for presenting the logic, the constituting process that sets them forth, which I would say was differential calculus. So if we now go to the recursions and computing, serial form and ornament, the calculated effect of today's computer-generated aesthetics would be impossible without the differential calculus. Of course, it has to do with what type of software program you're using. Computer and differential calculus-based processes seemingly determine the logical framework for the newly emerging ornament, at least for many of those, which nevertheless often expresses the logic metaphorically only through the differentiation of one basis module. And this is work of my own firm. The processes of differentiation and integration, a key to differential calculus, demonstrated that continuous curves and figures are composed of infinitely varying elements, which themselves can be infinitely divided into smaller elements, as this may show. Again, this is an early work. I would say it's a fetishization of surface differentiation, and as we also know, not all grasshopper quite well, not too complicated to achieve. Anyhow, for us, this was very important to do this work because we were very eager to link to these conceptual ideas a piece of work. That's essentially the tension our firm anyways works with. On one hand, the conceptualization, on the other hand, the practical outcome. A curve could now be analyzed as a composition of continuous points, each with infinitely varying tangent lines. Differential calculus also provided a method for the calculation and comprehension of forms and the changes they undergo. Notions of difference had to be rethought as oppositions between bounded entities were reconceptualized in terms of a continuous differentiation. This development fueled the creation of new aesthetics of continuous recursive differentiation that found its expression in surface ornament, which nevertheless often expressed this logic only through the differentiation of one base model. That was essentially the work I showed before. Now, turning to Greg's work, however, interpreted the logic of differential calculus differently in terms of its capacity to map flexible organization in which dynamic relationships replace fixed coordinates. Replacing the notion of a determinable substantial object entity through object versions, through relational constructs, the recursive process versioning offers an alternative perspective on the objecthood. And I think these the simple silverware here, you're probably all familiar with, I think shows this very easily. On one hand, we have here the set of points, which are the flexibles, and then you have here the diverse iterations of this possibly. And here we have even further iterations. So what I thought was interesting is that the whole question of what objecthood is, which usually was coordinated in the literal sense of the word with fixed coordinates in space, was here challenged through the operations which were recursive, if you wish. While unversioned objects may be considered objects that merely occur in a single state, namely the current, the present state, which becomes is here in this case, we're no longer talking about the object as such because it continuously becomes overwritten as it is modified, and each version presents a state of an evolving item put under version control. Versions may therefore be either performed as revisions, superseding their predecessors, or as variants, coexisting with their predecessors and antecessors. Each revision or variant, a snapshot of an instant in the evolution of the object is contained within the versioned object. Each revision or variant becomes solely identifiable in and through its complex relations to all other revisions. Links and relationships record the predecessors and successors as they permutate, and hence constitute the object differently each time. And an example of this is the silverware I'm showing here. What's interesting about it is also, as you probably all know, that Greg is not talking about objects at all. It's at best a family. It is a set of a series, and they are all based on one and the same primitive. In taking advantage of computational processes fueled by infinitesimal calculus, the design of the generic, functionless primitive is developed using software, and it relies on the differentiation in order to permit the interpolation of key points, and is then mutated to produce various forks, knives, and spoons, which of course also will have an effect on how we may eat with them. Within a recursive process following a clearly defined set of rules, Lin develops a great variety of different cuddly pieces, pragmatically and conceptually setting forth the power of computation, and I would argue here in this case the recursion is quite visible. So this is the urban adapter from my firm. Computer-generated designs displayed early on great degrees of differentiation, and yet the production of the differentiation remained until today a challenge. As here, the urban adapter by my firm exemplifies, in which all sections are differentiated and much effort was put into the coherent production and construction of, as we can see here. So this urban adapter is a piece which we did for Hong Kong. Hong Kong has a whole set of different styles of typical benches you can find worldwide, and yet, as you know, they're lacking tremendously civic space, and so the idea was to develop one type of urban furniture which could adapt to all possible different scenarios, and also which definitely would be able to walk upstairs, for example, because much of Hong Kong, as you know, has steep slopes. So part of the development was to think of different occupation schemes here, and then to figure out, and this is one version out of a whole series of possible versions, to see how far it either was, seating multiple people with here something for the back, or just a bench like that to lie also on, or becoming a panel, or even a box and a storage unit. So I would argue part of the ornament development here is also the representation of the piece, not only in its final version, and you could say the ornamental aspect of it are actually the section cuts, and of course also the form overall, but you could also argue that the way we present this, namely in the rationale that links these together and in a certain way maybe fetishizes also the construction process as such, is part of the discursive building of the new ornament, which I would say is a computer-generated and computer-fabricated ornament. So here, for example, a key of the problem was, of course, because all the sections alternate and change, and of course because each section had to be connected to the next, to find out within the envelope of these sections where these connecting pieces could occur. And each of them, you can see how they populated throughout. In the beginning and end of the piece, it's much easier, but then in the very undulated middle is rather complicated. That's the final project here. You see what I would call the ornament. It's heightening the differentiation, but also the discretization necessary in order to cut it. The material is recycled MDF. And this is a second project I would like to show. This is a work a group of students and I did at the GSD, the Graduate School of Design. And again, here it's a showcasing of how computational processes in conjunction with certain material requirements are continuously recalibrating one another. So this is a work which has been done with chipboard. Each of these units is made out of a flat piece of chipboard, which then was laser cut. And the biggest challenge for all of this was the assembly of the units, which we did in nightly glue actions. And then the overall assembly, which rather turned out disastrous. I think we learned still a lesson. So first of all, we the students developed a LIMACON surface, which then was covered with mass-customized apertures. Now, I think this piece in particular comes out of this time when everybody was still very interested in showcasing the capacity of differentiation and showcasing it through something built, because that was the ultimate proof that something like mass customization could be actually becoming a potential threat to what we still live in, and through which are mass-produced elements out of which most likely or most often we still build our pieces of architecture. So I think the shift the digital medium in the mid-90s has brought about is the continuous differentiation, and is a clear positioning against that which is standard or that which is a repetition of the same. And I think we do this also in a very rhetorical manner, meaning that we push differentiation for the sake of differentiation in order to make this very point clear. And I think this project has suffered from that to a certain extent. And I'm just going to quickly through this. So the surface is a continuous surface. This whole idea of continuity, of course, is to a certain extent here exercised and also, I think, celebrated, but you could say also to a certain extent fetishized. Then continuously great feedback where discretization thought of in how far this surface could be discretized, so that a structural condition would occur, which is this here, over here. So the surface was analyzed, and we looked into which moments would be actually make us, or would be in such a way structural that we could get this built in chipboard. Now, in the end of the day, unfortunately, even we put so much effort into the structure, the piece did not hold up very long and collapsed in the night before the review started, which was quite a disaster, you can imagine. But we learned the lesson, because what we thought of being one of the key structure components, so besides the unit itself having some structural depths, but I mean, remember, the seams were partially glued, some were folded, but there were still a few seams to be glued. We had also this here made out of chipboard, which of course was longer and would, go up the entire piece, and was thought as being the structural component, quote unquote, structural component. Here you see the unit unfolded. Many iterations had been developed in order to develop this unit. It looks maybe pretty simple, but the key question we had is how would we make the seams in such a way that, first of all, the folding was easy, and then at the same time also that the seams which would have to be glued were strategical, so they wouldn't unfold right away and would somehow resist, the whole piece needed to resist some type of tension and torque. And at the same time, of course, we also looked into in how far we aesthetically could hide the glue seams at our best. You see here all the details for attachment, and otherwise also details in terms of numbering, because, of course, as you all know, in the moment you do mass customization, every single piece needs to be numbered in order to find it back and put it back into its proper spot. So other part of the exercise was to see in how far these elements could be placed on material in order to waste as little material as possible, and of course also to match the sizes to that which we could manage in our fabrication in the GSD. So here we can see then the large effort. This is laying out the different pieces before they actually were attached. You can see this here. This is like the part of the whole piece laid out, and you can also see there's still a slab missing, which was in order to then tie it to that which became the vertical member and which is missing in this here as we laid it out. So essentially all of them had to be made, then organized by numbers, then tied to this vertical element in order to hold up, and then this slab had to be closed. So I think after that, pretty much everybody involved. This is Hiroshi Jacobs, and I see also Casey is here. Hi, Casey. After that, I think we all realized that mass customization is a great idea, perhaps. It's for our rhetorical purposes maybe relevant, but that in fact laboring it through a couple of nights and then seeing it collapsing in front of our eyes taught us a lesson. Last semester's workshop, I focused on strategic customization. That means that you are developing maybe a similar surface, but you're looking at organizing as little different elements on the surface without sacrificing, let's say, the curvature and the resolution of the overall piece. You can still ask why at all do we do these type of curved surfaces, but I think it's a challenge. Why not investing in it further? And I think in the strategical mass customization, I think there's a good way perhaps to find a medium between that which is mass produced and that which is mass customized. So let me see here. I'm going back to my script here. It is perhaps for this, so as here the urban adapter has shown, but also as this installation piece has shown, there is much effort that has to be put into a coherent production and construction of a process of standardized mass customized pieces. It is perhaps for this reason that ornamented surfaces of installation art and pavilions became the architects' celebrated realizations through which they hope to explore and profit the very premise of mass customization, the after-modern paradigm, as a valid counter-model to mass production, the modern paradigm. And I think that, as I said, I do not entrust this any longer, and I think we seriously perhaps need a reassessment of the situation and the problem, because I don't think that the paradigm of mass production has been challenged yet. The question is, do we have to challenge it? But it seems that a lot of the pain we go through, I'm wondering whether it's worthwhile that we go through it. Anyhow, I'm now turning around and discuss another type of ornament, which I think is linking very much to the previously discussed one, which is an ornament which I call the manufactured ornament. And this is an ornament in which the ornament is not only created through the designer or the software, but it's also created through the tools which in the end produce the software. And I think the actual realizations are not only marked through the desire to explicate hyper-differentiated surfaces consisting out of a large array of customized pieces, they also often highlight the computer-aided manufacturing process that brought them into being, which left its ornamental traces. Machinic processes and the product of their manufacturing can be thought together and comprehended as form, as a recursive process of formation in which form and ornament alike emerge. And I think what's interesting about it, of course, there are certain limits in the fabrication processes, as we all know, as you experience every day. The ornament here is the tool path to a certain extent, which, of course, by choosing the tools in different sizes can be either celebrated or suppressed, more or less suppressed, not entirely. And therefore, it is a kind of significant choice. And of course, also the undercuts are only to a certain extent possible. So there's a great feedback loop between the materiality chosen, the actual design, and then the possibilities we have due to manufacturing techniques. Now, you could also say that then in a total surplus, and I know somebody listening to me now was actually involved in this project and might be challenging me right away, to a certain extent then also the anticipation already of the tool path itself can become a design idea and a design device where you almost further exaggerate that which maybe on a smaller component of the same design was witnessed as being the trace of a tool path, now is celebrated as a component of the overall design. So machinic processes and the product they manufacture can be thought together and should be thought together as a form, as a recursive process of formation in which form and ornament alike emerge. In conclusion, design with computers is a recursive process, yet that in its current version does not radically challenge the ontological existence of both object and subject. In this respect, one could say that the ornament of the 1960s was more radical in its assessment of computational processes than today's computer-generated ornaments are. The problem seems to be that there is an investment, if not an obsession, in the continuous recursive adjustments of a design towards varying parameters. Ornament today is the ornament of computer-based processes that are currently expressed through surface differentiations. These ornaments are set forth through syntactical computational processes and gain, at best, a meaning through their association with discursive imperatives, which have run their course. What will be next? Thank you.